In this tutorial, I will demonstrate how to configure the RAK7244C Developer Gateway. I would like to thank RAK Wireless for sending me this sponsored product. It is the RAK7244C LoRaWAN Developer Gateway. I find this particular gateway interesting because it has a cellular backhaul which has not been featured in my previous tutorials. This presentation can be found at this link. All my LoRaWAN tutorials and presentations can be found at this link. While going through RAK Wireless documentation, I was a little bit confused of their many developer gateways. In case you are interested in one of their developer gateways, in the next slides I will give you a quick explanation what the differences are. The RAK developer gateways, or sometimes called RAK pilot gateways, are ideal for prototyping, proof of concept evaluation, or for demonstration purposes. In tutorial 28 and 28.1, I have explained the RAK831 pilot gateway. The RAK831 pilot gateway is shipped with a Raspberry Pi 3 Model B+, converter board with GPS, this is the GPS module, and a concentrator module with the LoRa radio. RAK Wireless has discontinued manufacturing the RAK831 pilot gateway, but you can buy it as LoRa Gateway Developer Kit without the aluminium enclosure. The LoRa Gateway Developer Kit contains these items, and when assembled it looks like this. It is a LoRa gateway with no aluminium enclosure. More information about this kit, see this link. RAK Wireless made improvements to the RAK831 pilot gateway, and its successor, meaning upgrade, is called the RAK7244 Developer Gateway. This gateway uses the Raspberry Pi 3 Model B+, and has two variants. Without LTE, meaning cellular functionality, it is called RAK7244 Developer Gateway, and with LTE functionality. This gateway is known as RAK7244C Developer Gateway. The C stands for cellular. This is what the RAK7244 Developer Gateway looks like without the cellular antennas, and this is the one with cellular antennas. Both gateways are shipped with the Raspberry Pi 3 Model B+, and the concentrator module containing LoRa radios and GPS. But only the RAK7244C Developer Gateway has the cellular module. On the bottom you see the Raspberry Pi 3 Model B+. This is the cellular module, but only for the RAK7244C, and this is the concentrator module with LoRa and GPS. More information about these gateways, see these two links. And here is a link to the shop. The RAK7244 Developer Gateway is redesigned for the Raspberry Pi 4. This new gateway is called the RAK7244 Developer Gateway. This gateway has also two variants, with and without cellular functionality. They are called the RAK7244 Developer Gateway and the RAK7244C Developer Gateway. The main difference between these two gateways and the previous two gateways is the use of the Raspberry Pi 4 Model B. The Raspberry Pi 4 Model B is used compared to the previous model. More information about these gateways, see these two links, and here is a link to the webshop. This video is mainly focused on the RAK7244C LoRaWAN Developer Gateway. The RAK7244 and the RAK7244C are almost identical, with the exception of the cellular hardware components. RAK Wireless has their own online web store. See this link. RAK Wireless also offers the same products on AliExpress. which is a Chinese online retail service where businesses can sell products to international online buyers. On AliExpress, the store is called RAK Wireless Store. See this link. One of the major differences between the two shops is the way the products are shipped. On their own web store, they are using the well-known shipping companies DHL, UPS, and FedEx. On AliExpress, you can also choose AliExpress standard shipping with lower shipping costs, but the delivery is not fast compared to DHL, UPS, and FedEx. The RAK7244C has the following features. It has an aluminium enclosure with Raspberry Pi4. It has full LoRaWAN Stack support version 1.0.2. It supports 8 channels and spreading factors 7 to 12. It has D's frequency band support. The maximum transmission power is 27 dBm and the receiver sensitivity is -139 dBm. It has a U-Block Max 7Q GPS module and a QuickTel EG95 LTE module. The datasheet of this gateway can be found at this location. When you buy the RAK7244C LoRaWAN Developer Gateway, you will get the gateway itself, the power supply, a 16GB micro SD card, the GPS antenna, one LoRa antenna and 2 cellular antennas. The power supply with USB-C. The total cable length is 1.20 meters. This is the micro SD card and the instructions where you can get the LoRa Gateway image. The LoRa antenna. This antenna is tuned for 868 MHz. And 2 cellular antennas. Only the LoRa antenna can be bent, like this. The cellular antennas are always in an angle. The GPS antenna, the total length of this cable is 1.50 meters. The LoRa antenna is attached here. The GPS antenna is attached here. And the cellular antennas are attached here. The micro SD card is inserted here. The SIM card is inserted here. And the power supply is inserted here. This is the Ethernet connection, the USB 3 ports, and the USB 2 ports. It's made of aluminium. The gateway disassembled. The Raspberry Pi4 Model B. It has 2 GB of RAM. The RAK7245 Pi head concentrator. This is the U-Block's Max 7Q GPS module. Below this heatsink there is the SX1301 and two SX125X transmission/receiving front ends. The LoRa antenna is attached here and the GPS antenna is attached here. And there is also 3 LEDs. This is the RAK 2013 Cellular Pi head. It has the QuickTel EG95E modem. This is the main antenna and this is the diversity antenna. This is a SIM card slot. The RAK7244C Quick Start Guide can be found at this location. The RAK Wireless software download area is located here. The RAK7244C firmware can be downloaded here. The firmware version downloaded and demonstrated in this video is this version. I will follow this quick start guide to set up the gateway. The installed firmware has the following software pre-installed: Raspbian Buster Lite. More information, see this link. The Semtech LoRa library version 5.0.1. More information about this library, see this GitHub page. This library is installed in this directory. And the Semtech UDP packet forwarder version 4.0.1. More information about this UDP packet forwarder, see this GitHub page. This UDP packet forwarder is installed in this directory. RAK Wireless has a GitHub page. See this link. The firmware source code can be found at this location. This is the quick start guide. Device firmware setup. First we have to download the latest firmware. That is this one. We need to install Etcher. We need to install Balena Etcher. I have a Mac operating system. I will download this version. When both files are downloaded, I will install Balena Etcher. As you can see, I have installed Balena Etcher. I have this adapter. Insert the shipped micro SD card in the adapter. This is my MacBook. Select image. Select this zip file and select open. Verify if this is the correct card. That is correct. Press the flash button. Insert the micro SD card in the gateway. Like this. I have done all these steps. Accessing your gateway. To access the gateway, there are two methods, using Wi-Fi or using the Ethernet port on the Raspberry Pi. I will demonstrate both methods. Please note, in this video, I'm using an iMac or a MacBook, so I will follow the procedures for the Mac operating system. Before powering the Raspberry Pi 4, you should install the LoRa, GPS and LTE antennas. Not doing so might damage the boards. Connect all antennas. At a later time, I will position the cellular antennas correctly, but for now, I will leave it this way. By default, the LoRaWAN Gateway will work in the Wi-Fi access point mode, which means that you can find an SSID named RAK Wireless and then some number on your PC Wi-Fi network list. Let's check this. As you can see, the RAK Wireless SSID appears in my Wi-Fi list. Select this SSID. Enter the password RAK Wireless and press the Join button. This computer can now access the gateway using Wi-Fi. The default IP address of the LoRaWAN Gateway Wi-Fi is this IP address. I have written down this IP address. I will need it when I connect it via SSH. Now let's log into the gateway via SSH. I'm selecting Mac operating system. Open a terminal. Switch to root mode by entering this command. And enter this command. And the default password is Raspberry. I have opened a terminal. Switch to root mode. Access the gateway by entering this command. Yes. I'm now logged into the gateway. I will now demonstrate the other method to access the gateway using the Ethernet port on the Raspberry Pi 4. So you need an Ethernet cable. The default IP address of the LoRaWAN Gateway Ethernet interface is this IP address. So you need to set the IP address of your PC Ethernet to the same network segment, for example, using this IP address. Alright, let's try this. First, I will disable Wi-Fi. As you can see, Wi-Fi is disabled. I can follow these steps. Connect the PC to the gateway using an Ethernet cable. Select Open Network Preferences. Select Ethernet Self-Assigned IP. Change this to Manually. Enter this IP address and this subnet mask and press the Apply button. Close the window. Open the terminal. And let's see if we can ping the gateway. As you can see, we get the response back. Now let's log into the gateway by entering this SSH command. Yes. Password is Raspberry. And as you can see, we are logged in. Now you know how to access your gateway. Here a quick overview what I have just demonstrated. To access the RAK7244C Developer Gateway, there are two methods. Method 1 using Wi-Fi and method 2 using Ethernet. Using Wi-Fi, then this is the gateway IP address. The SSID is RAK Wireless and 4 digits. And the password is RAK Wireless. If you want to use the Ethernet method, then the gateway IP address is this. You can see this is different than this IP address. If a computer wants to access the gateway using Ethernet, then the computer must set its IP address to, for example, this address. As you can see, the last 2 digits are different. And the subnet mask address is this. To log into the gateway via SSH, using method 1, use this command. And using method 2, the Ethernet method, use this command. This is the gateway IP address. This one belongs to this. This one belongs to this. In both cases, the username is Pi and the password is Raspberry. In this video, I've chosen for method 2. Now let's configure the gateway. Open a terminal. I've opened a terminal and I am already logged in the gateway using SSH. Enter this command. Okay, let's follow all these steps. Setting a new password for the gateway. Select Enter. Press Enter and enter my new password. Retype password. Done. And press the Enter key. Now let's set up RAK Gateway LoRa Concentrator. Select the second option, press the Enter key. I'm selecting the first option, server is TTN, and press the Enter key. Select a channel plan. If you do not know which channel plan to select, scroll down. And here's a link. Visit the article for more information on your local TTN frequency plan. This is the article. Select the country where the gateway is operating in. I live in the Netherlands. This is my channel plan, AU 863 to 870. That is this one. I'm selecting this channel plan. Press Enter key. Again press Enter key. And again press Enter key. In this video, I will not demonstrate how to set up Chirp Stack as my LoRa server. I will connect the LoRaWAN Gateway to a router. If you want to use the Things Network or an independent LoRa server, which may be deployed in local area network or internet, you need to connect your LoRaWAN Gateway to a router first, and that is what I want. and I want to connect it through Wi-Fi. There are 4 options. I'm using this option, Enable Client Mode and Disable Access Point Mode. Let's execute this option. First, select this option, Configure Wi-Fi. Select the second option, Enable Client Mode, Disabled Access Point Mode. Press Enter key. Okay, press Enter key. Again, select Configure Wi-Fi and select Add New SSID for Client. Select the country in which the Pi is to be used, that is the Netherlands. Press the right arrow key and press Enter key. And press again Enter key. Enter my router SSID and press the Enter key. Enter my router password. Press the Enter key. I have done this step, Enable Client Mode and Disabled Access Point Mode. Then I've added the SSID for the client, selecting the country of residence. Enter my router SSID and the router password. Connecting through Ethernet. In this video, I will not demonstrate this option. I will skip this step. Here is a quick overview of what I have just done. This is my router, which is connected to the internet. My router has this IP address, and this is my router SSID and my router's password. This is the LoRaWAN Gateway. As demonstrated, I have disabled Wi-Fi access point mode and enabled Wi-Fi client mode. I have entered the SSID of my router, that is this SSID, and entered the router password. The router will randomly issue a new IP address to my LoRaWAN gateway, for example, this IP address. My computer will still have access to the gateway using the Ethernet cable. The computer accessed the gateway using this command, but the password is changed. It was Raspberry and it is changed to something else. So the next step is connecting to an LTE network. I will do this later. I will continue with this step, connecting to the Things network. But first I exit the screen by selecting Quit and pressing the Enter key. For the next step, you need your gateway ID. Enter this command. This is my gateway ID. I will write it down. Before you continue, reboot the gateway. Enter the following command. After the reboot, I have removed the Ethernet cable. Then I have connected my computer to the router by entering the router's SSID and password. The router has randomly issued an IP address to my computer, for example, this IP address. My computer and the LoRa Gateway are both on the same network. Now, using my computer, I can log into the gateway using this command, using the LoRaWAN Gateway IP address, that is this IP address. And of course, using the password which I have changed. Go to the Things Network website, and I assume you already have an account. If not, create one. I am already logged in. Select Console, select Gateways, and select Register Gateway. Now let's register the gateway. This is my gateway ID. It is the same gateway ID I have written down earlier. Select this option. It is important that you select I am using the legacy packet forwarder. My gateway AUI only contains hexadecimal characters. This is correct. I can ignore this warning. This is my description, my frequency plan, I live in the Netherlands, that is in Europe. My antenna is indoors. I have entered my latitude and longitude. This location will be used if my gateway cannot determine its location by itself. Press the Register Gateway button. If everything went well, the status will change to connected, as you can see over here. Let's change this information. The brand is RAK Wireless, model is RAK7244C, and this is the antenna shipped with the gateway. I also want to make a change to the location. I set the altitude to 11 meters. Save location. It is important to select a router nearby your region to reduce the latency. I have unchecked both boxes. Press the Update Gateway button. As you can see, my gateway status is connected. But what if my status is not connected? What should I do? Well, you can apply the following checks. Please note, I've also added additional checks. First, check if you have access to the internet. Enter this command. And as you can see, I can ping google.com. Go to this folder. The local configuration.json file and global configuration.json file are located in this folder. This is the global configuration.json file, and this is the local configuration.json file. Open the local configuration.json file and check the gateway ID. My gateway ID is correct. Check if your gateway has the correct frequency. This is the label on the gateway, and as you can see, it says 868 MHz, which is correct. This is the correct frequency in the Netherlands. Open the global configuration file and check the server address parameter. My TTN frequency plan is this. This should be my server address, router.au.thethings.network. Open the global configuration.json file. Scroll way down. Here is the server address, router.au.thethings.network. This is correct. Enter this command to check the TTN gateway server status. As you can see, the TTN gateway service is running, and I don't see any error messages. Enter this command to check the log file. And as you can see, I don't see any error messages. Enter this command to check the system time. My system time is correct. If the system time is wrong, change this using the Raspberry configuration tool. Enter this command. Select option 4, select option 2, and select the geographic area in which you live. In my situation, it is Europe, Amsterdam. I've already done this, so I will select Cancel. Finish. Now let's check if the router SSID and password is set correctly. Enter this command and open this configuration file. And as you can see, my SSID is my router SSID and the password is my secret, which is correct. And check the disk space. Enter this command. And as you can see, I still have enough disk space. Here are some useful commands. How to open the gateway configuration menu, show the gateway ID and RAK gateway model and version, how to reboot the Raspberry Pi, how to shut down the Raspberry Pi, check the installed Raspbian version, use this command, how to restart the TTN gateway servers, use this command, stop the TTN gateway servers, use this command, and start the TTN gateway servers, use this command. The systemd services and units can be found in this directory. These are the relevant services related to the LoRaWAN Gateway. For example, if you want to know if the RAK LoRaWAN concentrator is active, enter this command. Or for example, you want to know if the Wi-Fi access point is active, use this service name, systemctl status followed by this name. The RAK7244C gateway configuration settings are stored in this file. Value 1 means enabled and value 2 means disabled. This is the file. Here's an example. Wi-Fi mode with value 2 means Wi-Fi access point mode is disabled. The gateway model and version are stored in this file. Unfortunately, this is a bug. The shell scripts gateway config and gateway version are copied to /user/bin. The RAK 831 and RAK 7244C uses the same Semtech LoRa library version 5.0.1 and Semtech UDP packet forwarder version 4.0.1. The RAK 7244C has GPS. If you want to know how to use GPS, see tutorial 28. More information about the global configuration.json file and local configuration.json file, see tutorial 28.1. If you want to know how to enable debug logging for Semtech LoRa Gateway and Semtech UDP packet forwarder, see tutorial 28.2. More information about Semtech UDP packet forwarder and the Semtech UDP protocol, see tutorial 29. And the Semtech UDP packet forwarder configuration files explained, see tutorial 30. My end node is running and it is 6 meters away from the gateway. This is the received sensor data. Let's open one. And as you can see, this is my gateway. This is the proof that my gateway can receive sensor data. I have installed TCP dump on the gateway. How this is done, see tutorial 29. With TCP dump, I can monitor UDP messages sent between the RAK7244C and the Things Network server. I can monitor the UDP messages. I have already installed TCP dump. Enter this command. And you can see the UDP messages sent between the gateway and the LoRaWAN network server. The RAK7244C LoRaWAN Gateway has several backhaul options: a Wi-Fi option, an Ethernet option, and a cellular option. Backhaul means getting data to a point from which it can be distributed over network. Before I demonstrate how to connect the RAK7244C LoRaWAN Gateway to an LTE network, it is useful to understand the evolution of cellular standards. It all starts with the first generation, that is the first mobile phone. The second generation is where we can send text messages. The third generation is slow internet. The fourth generation is fast internet. and as of 2020, the 5th generation. Each generation brought new functionality. It means lower range, lower latency, but higher data rates. In the world of cellular communications, GSM and CDMA were the two dominant cellular standards. Most of the world uses the GSM standard. These are 2G cellular systems based on the GSM standard, and these are 3G cellular systems based on the GSM standard. Instead of 4G, we call it 4G LTE or just LTE. LTE stands for long-term evolution. It is a standard for wireless high-speed data communications. 4G LTE means that this standard does not fully adhere to the 4G standards. 4G LTE can be divided into LTE MBB, which stands for mobile broadband, and LTE MTC, which stands for machine type communication. If we look at LTE MBB, it means higher data rates, higher power requirements, and higher cost, and LTE MTC means lower data rates, lower power requirements, lower cost, occasional connectivity. This is intended for Internet of Things. The Quectel EG95 is a series of LTE Category 4 module optimized specifically for machine-to-machine and IoT applications. More information, see this link. The Quectel EG95 has 4 variants: the EG95E, NA, EX, and NAX. The RAK7244C LoRaWAN Gateway supports EG95E or EG95NA. If you only look at the EG95E modem, it supports 4G LTE and these bands. I will explain what bands are in a minute. For 3G, it supports these bands, and for 2G, it supports these bands. The EG95E modem can be used in Europe, Middle East, and Africa. These are standardized frequency bands. For example, B1, referring to band 1, has these uplink frequencies and these downlink frequencies. Often band 1 is referred to as 2100. Band 3 is often referred as 1800 and has these uplink and downlink frequencies. For example, if we only look at Europe, specifically the Netherlands, it uses band 1, band 3, band 7, band 8, and band 20. And here's an example. Network operator XYZ supports GSM with frequency 900, referring to band 8. It supports UMTS with frequencies 900 and 2100, referring to band 8 and band 1. And it supports LTE with frequencies 800, 1800, and 2600, referring to band 8, band 3, and band 7. SIM cards, and SIM means Subscriber Identity Module, are available in the form factors 2FF to 4FF, as you can see over here. Industrial-grade SIM cards are also available in the form factors 2FF to 4FF, but they have thicker pin plate to safeguard the device from corrosion, vibrations, and other environmental factors. We have the SIM card Mini, Micro, and Nano, and these are its dimensions in millimeters. The smallest one is the Nano SIM card with these dimensions. The RAK7244C LoRaWAN Developer Gateway uses the Nano SIM card. Make sure that the card's gold contact faces upwards when inserting it into the SIM card slot. This gateway has no anti-theft features for stealing or replacing the SIM card. If the chosen cellular network supports, for example, GSM, UMTS, and 4G LTE, and in all 3 cases the signal strength is sufficient, the Quectel modem will by default use the highest possible speed, which in this case is 4G LTE. For this tutorial, I got this SIM card. Remove the Nano SIM card. This is a nano SIM card. Insert the SIM card. For demonstration purpose, I bought a 4G data bundle with 500 megabytes. The SIM card is free and the 4G data bundle costs €5. The bundle is only valid for 28 days and can only be used in the Netherlands. For more information, see this link. The cost is €1 per 1 megabytes. LoRa is a telecommunications company operating in many countries. I'm not paid or sponsored by LoRaWAN.com. LoRa Netherlands uses the KPN network which supports GSM, UMTS and 4G LTE. An access point name is the name of a gateway between a cellular network and the public internet. LoRa access point name is Internet. An end node sends a LoRa signal to a LoRaWAN gateway. It uses a cellular backhaul, in this case LTE. All these cellular towers are part of an LTE network. The received data is sent to a cellular network gateway, and from here it is sent to the Things Network server over public internet. Cellular communication systems uses two antennas, the primary antenna, aka main antenna, and the diversity antenna, aka div antenna. The primary antenna is used to transmit and receive. The diversity antenna is used to receive only. The diversity antenna is used to filter out the usable signal from the background noise, which increases the quality and reliability of the cellular system. The RAK7244C LoRaWAN Gateway also has two cellular antennas. These are the RAK7244C cellular antenna parameters. See this link for more information. This is the cellular antenna. I have measured the cellular antenna parameters with my vector impedance analyzer, the N1201SA. I've only done one measurement for 800 MHz. Here's a VisWAR plot over this frequency range and the corresponding S11 plot. And here is the impedance plot. This is the LoRa antenna. Unfortunately, I could not open this antenna. These are the LoRa antenna parameters. This LoRa antenna should resonate at 868 MHz. As you can see, the antenna performance of this antenna is not great. This is the VisWAR plot and the corresponding S11 plot. And here is the corresponding impedance plot. For the best wireless communication performance, it is recommended to align both the cellular antennas and LoRa antenna vertically. As you can see, the LoRa and cellular antennas are not vertically polarized, so don't do this. For better cellular antenna performance, I've placed the gateway on a box. The two cellular antennas are now vertical polarized. The LoRa antenna is also vertical polarized. The RAK Wireless shop offers different antennas with better gains. See this link. Or you can build your own LoRa antenna with a better gain. See tutorial 41, 44 or 46. If the RAK7244C gateway is using the Ethernet or Wi-Fi backhaul, it is recommended to leave the cellular antennas connected. Unconnected ports can cause reflections, which can fry the cellular modem. Unconnected ports can also gather dust. To make sure I'm using cellular backhaul, I have not connected an Ethernet cable to the gateway, and on the gateway I have enabled the access point mode and disabled the client mode. The gateway's Wi-Fi is now in access point mode, which means my computer can access this gateway using this SSID and the password which I have changed earlier. When I have configured cellular backhaul, sensor data from the end node received by the LoRaWAN Gateway can only be forwarded using the cellular backhaul. The Quectel E95 modem can be controlled with the Minicom program. Minicom is a text-based modem control and terminal emulator program for Unix-like operating systems. To open Minicom, enter this command. And you can enter AT commands, like this. To show Minicom command summary, press the keys Ctrl and A, and then press the Z key. This is the Minicom command summary. After I press the Add command, you should see OK. If you don't see OK, in this screen, press the E button to enable local echo. Press the Q button to quit with no reset. And then select Yes. As you can see, the port was /dev/tty-ama0. To check if this is the correct port, enter this command. As you can see, tty-ama0. Add commands are instructions which are used to control modems. Add is an abbreviation for attention. Each command starts with the prefix AT uppercase or AT lowercase, followed by the command itself. There are two types of add commands. Basic add commands. These commands do not start with the plus sign. And extended add commands. These commands start with the plus sign. More information about the Quectel EG9X add commands, see this PDF file. Now let's start with the demonstration. I've selected this option, connecting to an LTE network. I will follow these instructions. I've inserted a SIM card. I've logged into the gateway through SSH, and I will start with this command, sudo gateway config. Enter the command sudo gateway config. Select option 7, configure LTE module. Select option 2, disable LTE automatic dial-up. The LTE module is disabled, select OK, and select Quit. Enter this command to check if the LTE module is disabled. As you can see, the LTE module is disabled. Enter this command to start the Minicom program. Enter the add command. You should see OK. Enter this command to look for all available LTE networks in range. It may take several seconds for a response. This is a list of available LTE networks. Now search the list with 0 as value at the end. So this is value 2, this is value 7, and this is value 0. This is the currently used network. The second parameter is the network operator name, and 0 means that this is the currently used network. To use this LTE network operator, enter this command 1, 0, and then NLKPN is this, NLKPN, followed by this 0, 0, referring to this 0. Press the enter key. An OK is returned which means the QuickTel modem is configured with this LTE network operator. Exit this Minicom program by pressing Ctrl A, press the Z key, and press the Q to quit with no reset, and select Yes. Again, open the Gateway Configuration tool, enter this command, select option 6, configure APN name. The APN name is Internet. The APN name is Internet. That is the access point name used by Lebara. I have explained this earlier. Press the Enter key and keep the default baud speed 115/200. Press the Enter key. Quit the setup. The LTE network is now configured. Now let's test and verify the connection by entering this command. You just saw a series of logs. If you see local and remote IP address with DNS addresses, it means a cellular connection has successfully been established. Press the buttons Ctrl Z. Open the Gateway Configuration tool. Select again option 7. And now select option 1, Enable LTE Automatic Dial-Up. Press the Enter key. Press the Enter key. Select Quit. Reboot the gateway. After the reboot, I am again logged into the gateway. Enter this command to see if the LTE module is active. As you can see, the module is active. I'm logged into the Things network. Go to the console. Select Gateways. After a minute, you will see that the gateway status will change from not connected to connected. I've started my EndNote, and in my Applications Data Console, let's open this, I can see my gateway. This is the proof that I'm using the cellular network. When an end device transmits sensor data, the LoRaWAN Gateway does not only transmit this data to the cellular network, it also adds metadata to the sensor data. Besides the sensor data, the LoRaWAN Gateway also transmits at regular time interval the gateway status to the LoRaWAN network server. For more information, see tutorial 29 and look for this parameter, stat interval. Also, the gateway transmits at regular time interval a keep alive message to the LoRaWAN network server. For more information, see tutorial 29 and look for this parameter, keep alive interval. Both intervals are set in a global configuration.json file or local configuration.json file. In both cases, acknowledged messages are sent back from the LoRaWAN network server to the LoRaWAN gateway. The LoRaWAN network server can also send downlink responses back to the LoRaWAN gateway. The cellular data usage not only depends on the actual sensor data size and response data size, but it also depends on the stat interval, keep alive interval settings, and, of course, how often sensor data and responses are transmitted. I have created this overview. The gateway sends sensor data to the LoRaWAN network server, but it also sends gateway status, and it is set by the stat interval parameter. The gateway also sends keep alive messages to the LoRaWAN network server, and the LoRaWAN network server can also send responses back to the gateway. In all cases, acknowledged messages are sent back. Here is acknowledged message sent back. Here is acknowledged message sent back, and here is acknowledged message sent back. The RAK7243C and RAK7244C LoRaWAN Gateway cannot whitelist endnodes. This means when using the cellular backhaul, you will also pay for cellular data packages from other end nodes not owned by you. If you want this whitelisting, please leave a comment below. Maybe RAK support will implement this functionality if they see many viewers have requested this functionality. Thanks for watching. I hope you enjoyed the video. Please hit the like button and don't forget to subscribe. If you have questions, leave your comments below. I'll do my best to answer them.